Okay, I'm very pleased to introduce our speaker today, Dr. Amanda Harsy from Lewis University, and she will speak about mastery-based testing in mathematics.
Thanks. I realize I'll pull out the chat. It's all my classes are in person, and I feel like I'm a little rusty with the Zoom. There's something that it seems like I'm not connecting correct. Just let me know. So thanks for having me. I'm going to talk a little bit about mastery-based testing, and I know that the trend right now is to not to use the term mastery with kind of some of the connotation of the master slave connotation for that. So I feel like a lot of people who are doing mastery-based testing is actually going into more of phrases like grading for growth. But I've done a lot of research, and my colleagues and I use the term mastery grading. So I'll kind of use both here, but I just kind of wanted to mention that that's one of the things that is kind of changing here. I also want to mention that the slides that I have here were kind of adjusted from a webinar and a mini course that I worked with Jeb Collins, Alyssa Hoofnagel, and Jessica O'Shaughnessy on. So that was, those were over multiple days. So this is a little bit more of a condensed kind of overview of mastery grading and kind of what it is. And what I really like about it is there's a lot of different ways you can do this kind of alternate assessment. And it's kind of a big tent. And I feel like this, what I'm going to talk about today is a really good, if you're interested in starting one of these alternate grading systems, this is a really straightforward, easy, I like to think of it as the gateway drug of kind of alternate assessment, especially with grading for growth. So I feel like it's an easy stepping stone to do more elaborate things with standards, space, and specifications. They're all kind of overlapping and have a lot of ways that you can take pieces from each of them. But I feel like this is one of the more basic stepping stones. So my plan is to introduce this kind of system. We'll talk about what it means to grade on a mastery scale or a tiered scale. We'll show a lot of different examples of structures from classes so that you can maybe get ideas of if you were wanting to implement this in your class. Talk about how we can do reassessments, tips for organizing problems and keeping track of grades, and also kind of talk about some of the common challenges that might come up when you use this type of alternate grading system. So one of the things about me, just so you know where I'm coming from. So I teach at a mid-sized regional liberal arts school outside of Chicago. My typical load is 4 courses a semester. This semester I'm teaching 5. I've been using mastery grading for almost a decade now. I've used it in Calc 2, Calc 3, linear algebra, graph theory, and real analysis. And they all are a little bit different. I also have done multiple SOTL studies with mastery grading within different courses. In fact, my colleagues and I are currently conducting some research on the impact of this alternate grading system across several universities. So we're hoping to analyze our results in a couple of years after we've collected some data. So first of all, what is mastery grading? So this is kind of a grading scheme that where you split up the whole curriculum into clear learning objectives, and the grades of the students aren't really based on percentage of points, more just on their ability of whether or not they can demonstrate conceptual understanding of the concepts, which we often term mastery of the objectives of the course objectives. Because we have a higher scale for this, we usually have to, and it's expected to allow students to have multiple opportunities to demonstrate this mastery. And overall, usually the grade is based on the number and types of objectives which have been mastered. And so that's kind of it's more of a way of checking did the student demonstrate understanding of certain concepts throughout the semester. Some of the reasons to switch to mastery grading. So some of the things that my colleagues and I and other people who have worked in this area, that one of the things that we want to instill in our students is a growth mindset. So a lot of times when you start doing something, especially in mathematics, you're not so strong at the beginning, but through practice, you can become better and better. And so sometimes when you do traditional exams, they don't, at least I was noticing that my students were not revisiting ideas that they hadn't understood from the exam. They just are like, oh, I didn't get that. And then they're done with it. But especially in math, a lot of our concepts build upon themselves. And so you can't just say, well, I didn't get slope, hope I never see that again. And so we wanted something that kind of encourages students to actually revisit what they didn't understand. We also didn't want them to kind of just try to cram or memorize and just kind of regurgitate. So we wanted something that kind of, or I don't know about you, but I feel like I often see students who just try to they mimic the solution. They think that like they're trying to if I can just get a few more points to this, or I'll try to show that I understand, but they're just kind of writing something that they think looks right. I especially noticed this in work and hydrostatic force problems in Calc 2, where they're just I think there's an X somewhere, and they put that in. And we also kind of wanted to change kind of the focus of not I don't know about you, but I would always get the students of why did I miss this many points for this? Or why did I can I get a few more points on this? And so we wanted them to be more focused on, did you actually understand the material or not? We wanted something that kind of helped with anxiety. A lot of people deal with test anxiety or mathematical anxiety. And so we thought that if we had something that, one of the nice things about mastery exams is that you have multiple opportunities to demonstrate mastery, which lessens the stakes for each assessment that you go through. So that's actually something that my research and several other people who have done research in this type of alternate grading have actually found more concrete results of students feel less anxious when they use this type of assessment, along with standards-based grading or specifications grading. I also have personally found it to be flexible. I had a student who was sick for 2 weeks, and they were able to make up and kind of learn the material at their own pace and and demonstrate mastery throughout the semester. So I thought that was really nice. And also I like grading these types of exams better than others. Right now, my Calc 2 class is using traditional exams for my research. It's the control. And you always put your rubric down and you think, okay, I've caught every mistake that a student's gonna make. And then they always surprise you. And you're always well, I don't even know how I'm supposed to take this off. So I really like that it's more holistic grading, which makes it a little bit easier for me when I'm actually grading through. So there are many different ways that you can kind of grade using this kind of tiered scale. Often those people who are using mastery-based testing, we only give credit if a student has demonstrated mastery. And so some people just use a binary scale of did you master this concept or did you not? But some will divide into multiple groups. So I use a three-tiered scale. So I use a mastery if the student has definitely understood the concept. They may not have a perfect answer, but they have shown conceptual understanding of the concept that I'm assessing, and we'll do a couple of examples and we'll talk a little bit more about that. And then we have usually a mid-level. I use journeyman, but I don't really like that name. There's also some people use progressing. Some of my colleagues do, and they don't like it either because then it's a P and they think it's pass. And so they're, but kind of a mid-level indicator. And again, what you're doing when you're doing this kind of tiered grading is you're giving feedback to the student. So this progressing middle term is more of you were on the right track, but you haven't shown full conceptual understanding yet. So you need to revisit this. And then usually we have something like novice for the lowest level, which is you really need to look at this a lot more, you're a lot farther away. So some people get rid of that middle tier because they're they don't get they either master it or they don't. But I kind of like it because I feel it's more for encouragement for the students of you're on the right track. So let's kind of see how this would go in person, or like kind of like an activity. So this is not, I've actually never used mastery grading in an algebra course, because I just haven't taught algebra in a while. But it's a simple enough example. And so here we have the mastery objective on the left says like, the general ideas like finding equations of lines, and we want a question that kind of talks about, we want the student to be able to find the slope of a line, apply the slope point form to find the equation of the line, and also write the line in slope intercept form. So I know everyone wants to do more grading, right? Right now. But if the question was write an equation of the line passing through these points, and we have the solution over here, and we have the student solution. So if we were going to grade this on like a thumbs up, on the right track, or thumbs down, what would you kind of think if you were going to grade this particular student C solution? We definitely wouldn't consider it to be showing demonstration of mastery of this, I don't think, right? So I at least saw one person give a sideways. I'd say that was pretty far off, because they even misunderstood what like the slope intercept form. At the very least, I would also give a novice if I were doing this. But I like, the point is it doesn't really matter, like they wouldn't have mastered it. They need to revisit this again. So one of the things that when I'm grading something and I want to know, like, is this a mastery like grade or not? Like, have they shown complete understanding? I ask myself, would this student benefit from revisiting a question like this again? And I would say the answer is definitely yes. So I would not give them a mastery. I would probably give them a novice. We could do another one. Now, on the other hand, my guess is if I were to ask you, and I won't for the sake of time, but a lot of times when we do this type of mini course or something, we'll ask everyone to now grade this on a 10-point scale. And you'll see a lot more varying of the grades because of how people like decide to grade. But most of us can all come to a general consensus of like not mastered. So the second one, here's another solution. When we look through this, they don't quite have the slope correct, but they're on the right track. So if I was wanting to, I can find the slope of a line, I would say that they definitely haven't shown mastery of that. But they're definitely a lot further along than the previous student. So I would probably say this was like a mid-level grade, but I still feel like this student would, again, benefit from looking at this again. So I wouldn't consider this a mastery grade. Now, our third one, this one's a little bit trickier. So look at what this, take a moment and take a look at what this student has done. So where is the mistake with, so this is not the correct answer, but what type of mistake did this student make? Right, it was a small algebra mistake where they distributed wrong. It's a small, like a sign error. So has the student shown that they can find the slope of a line? Yeah. Do they definitely have set up the point slope form, and they definitely then rewrote it to try to write it in slope intercept form. So this is an example where I would probably give this a mastery, because even though they didn't have the right answer, they've shown right. But that's a good point. So Eric says, but what about the number sense? So I would say what I'm trying to determine here is if these were my three objectives for, I would say that the student has demonstrated they have made a small clerical error, kind of issue. But if your goal in this problem is to get some idea of number sense, you can decide that this is not a mastery when they do, I want all the algebra, because this is an algebra class, I want it to be perfect. If I were teaching a Calc 3 class and I was doing mastery grading and they were doing a big Calc 3 problem and this was the mistake that they made, yeah, they should be more careful. But the whole conceptual understanding, if everything else was right, I would probably give them a mastery. even in this one, I would probably give them a mastery on this, even though I agree that this is an algebra. What we're trying to test in algebra is that being very careful of the thing. So the question, so keeping the objectives need to be concise, right? So we can keep our focus narrow to the concepts involved, even though their skills could be a little clunky at times. That's what I usually do. But here's another thing that you can do, and that I'm getting ahead of myself a little bit, but I feel like it comes up with this question a lot. So like, if I'm someone and I would like them to, so one of the, I think it's David Clark who uses like either precision of language or attention to detail. You could include like a concept in your class of like, I want attention to detail. And like, in this case, they have not done a good job of attention to detail. And you could require them to, on X number of like concepts, to have to demonstrate this attention to detail. So that you're kind of assessing that, like, I want them to still be very, very good with like all the little nitty gritty stuff that they have to do with algebra. So there are ways if you, and one of the things I found when I started using this grading system was like, I thought I wrote a great question. And then I realized I did not answer it well. So for example, what if like right now, this question is not a really good question to assess the objectives that I have here. So the objectives that I have, I can find the slope of line, I can apply the point slope form, and then it says I can write a line and slope intercept form. What would you do then if the student had stopped after the first line? What if they had stopped in the point slope form? Technically, that is an equation of a line passing through these 2 points, right? But if I want to assess their ability to write the line and slope intercept form, that's on me, right? I needed to actually say and write in slope intercept form, or write it into 2 things. Yeah. Right. So like one of the things I've noticed is that you can have these questions and you think you're assessing what you want, but you're not. And so that's another thing that I like to mention here. And Derek has another question. So having overarching standards for mathematical credit that can be applied to every problem, right? And that, Derek, is actually going into, so that I feel like is the next step. So mastery grading or mastery based testing, I feel like is a very we often only do it for exams or assessments, but standards based, you can start adding more I would like these other types of objectives in my class of like number sense or precision to detail or correct units. And you can add those things and kind of require students to hit those a certain number of times throughout the semester. Right, for the actual intercept, right, or ask for the actual intercept, yeah. So like that's, there's a lot of variety that you can kind of like make this type of assessment assess what you want. And there's some nice freedom with that to be able to think about like, oh, how can I reach the object, like what I'm trying to assess correctly. So I'll kind of pause, like we can get into the weeds of like, what would you do in this situation? What would you do in that? And these are all some of the common challenges that we'll talk about at the end. But these are, what I really like about it is that in the end, like I can make kind of the decision, and I can learn from my own mistakes of like writing a bad example question. If I wanted to test slope intercept, I better make sure that they're required to write something in slope intercept form. So one of the things that we often do in mastery grading is we often have these, so I feel like in standards-based grading, you often have these different assessments. You can maybe demonstrate things on a homework a certain number of times, but with mastery grading, part of why I feel like it's the gateway is because you're only dealing with this type of assessment on exams or like quizzes. And so what I usually do, and what my colleagues who also helped with this workshop usually do, is we, if we have a certain number of or if we have a course, we break it into a certain number of concepts. And often for me, these turn into like, if I have a 3 credit hour course, I often have a roughly 16 concepts. If I have a 4 credit hour course, I have 18. But I have friends and colleagues who use 24 or who use 10. Like, it all depends on what you're kind of looking for. And then what we do is we often have either in-class assessments, like normal exams, or other retesting opportunities. So one of the things that I learned, I first did mastery grading with real analysis. And what I did was I broke up the concepts into a certain number of like exams. So for example, I'll skip ahead to the next slide. So here's an example with Calc 1. Here is an example. I've actually never used mastery grading Calc 1 because I haven't taught Calc 1 in many years. But my colleagues have, and this was how they broke up some of the topics in Calc 1 between the different exams. And so what you do in mastery grading is exam 1 will have these 4 concepts on there, and students have a chance to master any of those concepts. Then exam 2 will have all of those concepts again, plus all of the concepts on exam 2. Students can pick and choose which concepts they want to try to attempt to master. And if they've already mastered something, so for example, say on exam 1, they mastered the first 2 concepts. Once they've shown mastery of those concepts, they don't, even though they'll have questions on them on the next exam, they don't have to do them because they've already earned credit for those. So what happens is each exam kind of gets bigger and bigger, but you get to reassess any of the different problems. When I did this with real analysis, they only had reassessment opportunities on the next exam. And then the next semester, I decided I was going to use it for Calc 2. And the students in Calc 2 are not my students in real analysis. And they were not going to be able to master all the concepts with only a few tries. So I had to come up with an idea of like, how are we going to allow them to practice or demonstrate mastery more than just in the exams? So sometimes people will do kind of other retesting opportunities, and we will kind of talk about some different ways to do that. When I look at my grading for this, for like an exam, you also have to think about like, okay, how many concepts mastered will give the student what type of exam grade. So often what I do when I do these is I figure if they master at least half of these concepts, that should be a C. So I usually break it down so that like the first 8 concepts that they master in any order are worth like 9%. And then after that, they're worth like 3.5%. So kind of as they're kind of building their grade up throughout the semester. Other people will start, everyone will have like 100% for their exam, and then you remove a certain percentage for any unmastered concept that they don't have at the end. So another thing, and this is a question I usually get asked around now, is like, but wait a minute, so you weight all of your concepts equally, but you know, if a student doesn't know the chain rule from Calc 1, they're gonna really struggle in Calc 2 and Calc 3 later. So one of the things that you can do, kind of a variation of this, is to kind of denote some of your concepts to be core concepts, or like emphasize that they should be weighted more than others. So I do this when I teach Calc 2. And so I have those special like kind of core concepts are worth more percentage wise. So for example, in my Calc 2 class, I have 7 core concepts that are worth 10% of the exam grade. So any one of those that you don't master drops your exam grade a lot more than the other concepts. And this is a way to kind of signal to your students that this is what is more important to work on than some of the other concepts. So you can decide to do that in your class. And I do it for Calc 2. I would probably do it for Calc 1, but I don't do it in Calc 3 because it's not as much of a gate or like a sequential course. And I don't do it in linear algebra, and I don't do it in real analysis because those aren't like, I don't feel like those have, it's not as important for me to denote core concepts for those, but I definitely could if I wanted to. And if I felt like, oh yeah, I actually really feel strongly about this. So here are some examples to give you an idea of like how some people have done some of their mastery grading. So here's someone who they use 20 concepts in pre-calc. They use 15 to 18 concepts in calc 1, 2, and 3. They use 4 exams. I know I use 4 exams for calc 3, but sometimes you can do that among 3 exams, and I'll show an example of that on the next slide. Sometimes people have a final exam, and that's usually just all the concepts they've already like could have mastered, and then they have one more chance to retest those. Some people do reassessment quizzes, or like allow students to retest on a quiz between exams to kind of help add to their mastery level. And this person in particular used kind of like they removed a certain percentage for each concept. So here's an example concept list for like Calc 2, a way to kind of structure this. It looks similar to my Calc 2, kind of the applications, the integration, and kind of the late transcendentals, and then the sequences and series. Here's an example for Calc 3. My Calc 3 covers more vector calculus than this topic, so I end up using 4 exams. But this is another way to kind of like split up, a possible way to split up the course. Here's an example from linear algebra. So I'll talk a little bit about how I do reassessment. So some people like to use quizzes, but I like to give as much flexibility as possible for my students. And I'm very lucky, my university has kind of a tutoring and proctoring center. And so what I do is in between exam weeks, like if I have exam 1 and I have a couple weeks before exam 2, one of those weeks between I'll denote as being a retesting week. And a student can come in and retest any of the concepts that they want. They just can't retest it more than once throughout the semester. So like, and it can be open the whole week, and they can stop in either my office hours or the proctoring center. And so like if they have 20 minutes and they want to try to master one of the concepts, they can go do concept 2 on like Tuesday, and then they could try concept 3 and 4 on Wednesday, but they wouldn't be able to retest concept 2 if they had already done it before in the week. And so what I really like about this is it gives students some flexibility. They don't need a whole chunk of time to like try to reassess all the problems. And if you have more problems that you need to reassess, you just have to spend more time reassessing during those weeks. And if you don't, then you don't need to spend as much time. I like it also because then I don't feel like I have to be running all these office hours to have students come in. And I also like it because then I don't have to spend class time for reassessment. So one of my friends actually at Lewis, she would every Friday just have a reassessment quiz, and students would have to tell her which concept they wanted to reassess. And so she said it was hard because 1, it took class time away, and 2, it was hard for her to keep track of all the students' wants and needs of which concept they wanted to do that week. But that has worked really well for some of my other friends and colleagues who've done this. I like using the retesting weeks. It's worked well, but I also am in a situation where I have like a proctoring center where like I can utilize that. Let's see. So here's an example for linear algebra, like kind of how I split it up. One of the things I also like to do in my classes is I like to front load my exams. So I usually delay my first test to have more concepts on it, because then students will have more opportunities to reassess those concepts, and they don't have as many opportunities to reassess the 3rd exam because they only have exam 3 and then like a retesting. I usually have the finals week as a retesting week, so they can come in at any time. So one of the things I do for that is I actually allow students to reassess those last concepts on exam 3 twice during the retest or the final retesting week to kind of give them an extra opportunity. I've never used mastery grading in discrete or abstract, but here are some ways to think about those. So like mastery-based testing could be like a mixture of proof techniques, or like kind of also allow like kind of, you know, you could have kind of content focused or proof techniques. I have used them for real analysis. So one of the things that I do is I have a mix between mastery exams for like the classic real analysis problems, but then I also have them do take home exams on like the more like more creative or harder proofwriting skills. And then I actually assess that through an oral exam, which is a totally different thing I could talk about at a different time. One thing that you can do with like discrete math is you could have kind of, I like this. So if you have a class that has a lot of like, you know, group work and you want to make sure that like students are doing like good classroom community, you can make that be one of your concepts or objectives that you want students to master or get a certain number of masteries of. So you can be creative about like what you want to emphasize in their grade and make it part of the mastery grade if you want. Here's an example of splitting up of abstract algebra. And we also have, I don't know, does anyone teach statistics here? So I also have an example for intro to statistics. They use 3 exams. They have 15 concepts, and they split up their exams in the following way. I've never taught this particular class, but I kind of wanted to give you guys a bunch of different examples of different structures. So I have a question. Do you need to build a huge? Yeah, well, yep. That's what we're going to talk about next. So that's going to get into the nuts and bolts of that. So yes, we will definitely talk about that. So nuts and bolts of grading for growth. It's like you knew what I was going to say next. How to structure reassessments. I've kind of talked about that a little bit. How to organize problems and test banks. And finally, what are some ways of keeping track of the grades? Okay, so reassessment. There's already kind of a basic structure of reassessment. Old concepts from past exams will come up on future exams. And one thing I want to emphasize is that the problems change, but the concept that you're trying to assess doesn't change. So you shouldn't just repeat the problems, and it should be, for some questions, it is just a matter of like, you know, changing some numbers, changing some shapes. But it should be a rich enough question that students should try to, or not be encouraged to mimic solutions. So reassessment, you already have it with your exams. You can also do something. So here are some ways you can do 1 or 2 concept quizzes during the weeks between exams. You could retest by request. During office hours. You could use testing weeks like I do. Some people also give students a certain number of tokens that they can turn in when they want to reassess. One of the things I want to emphasize is that you shouldn't give, or at least we have found that students who are given infinitely many chances to reassess usually struggle because they don't focus enough on the reassessment, and they just try to like kind of put out something really fast. So I had a friend who was just like, you can reassess as many times as you want, but then that person was making so many different like versions of concepts. It was just, the work was overwhelming, and the students were just trying to like get by. They weren't really focusing on it. So I would recommend not making it be completely like, you know, as many reassessments as you want. But I also, one time I taught a linear algebra class, and I thought, at one point in the semester, I was like, they're not where they should be. So I added an extra retesting week. And that was a good way to kind of like encourage and allow students to like reassess some more in a like kind of controlled, reasonable way. So that's one thing, limit the number of attempts. Now, I don't know about you, but some of our classes are like night classes or only meet once a week. And so those are like condensed classes. So one thing you could do, or maybe you teach like a J term or something, ideas for reassessment when you have that fast, like kind of condensed class, or you're not meeting as often, is to, you know, you could have testing weeks where concepts are added per week. Like if you're doing like a J term, you could have daily quiz opportunities at the end of like a longer class. And the only thing we would mention for that is that you would need to kind of give a fast grading turnaround. So that they like knew where they were at and which concepts they needed to reassess. Okay, organization. So this was the question before. So it's really nice to try to think about like your course, like divide it up into the concepts and come up with like a good problem for each of those concepts or several problems for each of those concepts. And come up with like 4 to like 10 or however many different problems you want. Now they say create them before the semester starts. And I will tell you, I like rarely ever do that because I'm bad and I like wait and then I like make them up again. And like, but ideally you would want to make these before the semester. But I also do as I say, not as I do in this case. And I feel like if one of the nice things that can save you if you do it ahead of time is then you can like kind of pick and like you could pull this one and this version and that version, or even randomize it if you are a good programmer of like come up with like an assessment through this. Another thing for organizing grades, and I don't know if we'll have time for this, but I do have some slides that give some examples of how to like kind of organize the grades in like an Excel or a learning management system. But mostly it's important to just be able to think about how you want to communicate the grades to the students, how many tiers you want, and how do you want in their grade book for them to do. So we use Blackboard, and I just use like a 0, J, or an M. And like, then I have a sum of like how many concepts they've mastered. And then I have like a, this is your exam grade score right now. But there are a lot of different ways you can do that. So one of the challenges for this is writing learning objectives. So there's a lot of different ways you can think about this. I think it's just important to make sure you're thinking about which skills and concepts you want your students to be able to know at the end of the class. And I wanted to emphasize that sometimes, like, so here's an example from like derivative techniques, but I want to emphasize that sometimes one question won't be able to assess all the things you want in the theme, and that's okay. And this is an example of that. If I want students to know some derivative techniques, and I have our standard objectives within the derivatives, here's an example problem that a colleague of mine has used to assess these. So note that it's 3 problems, like, because they want them to be able to apply all of these different things. So you can do that for like, you can have these 3 problems are under one objective. Okay, now the question is like, this becomes a little harder. It's really nice if you have one problem that's rich enough to assess all the things you want, because then it's very clear, did they master it or did they not? One of the thorny issues when you have multiple questions is, what if they mastered 2 of the concepts, or 2 of the sections, but not the 3rd? And that, I feel like, becomes an instructor decision on that. And I often am guided, as I said before, of would this student benefit from revisiting this again? And that may be something different. Like if it's their last chance, if it's finals week and I know they can't reassess, then I may need to think like, did they demonstrate enough mastery of this concept to earn a mastery or not? So that is something that I feel like it's more on us, but that's one of the harder parts of like this grading system. So how do you write so many versions of these problems? Okay, some are really straightforward. For differentiation and integration and limits, a lot of those are just changing numbers, and there's not really much more you can do. You can change functions, and you can kind of, if they don't understand the concept, changing those things will be enough to like throw them off. Larger problems, it's kind of nice to have a small number of problem types. So for example, when I do Calc 2, one of my favorite ones to use is hydrostatic force. And I'm calculating the hydrostatic force of a plate under or above the water. And you can just rotate that triangle or change the shape and move it above or below the water. And those are the different ways I vary the problem. And they should be able to show conceptual understanding no matter which way I like move it around. There's another really great thing that people do is you can have free-form problems, like generate blank that has these properties, come up with a parametric line that is perpendicular to this line. These can be hard to grade with a point system, but they're pretty easy to grade with mastery. Like, did they understand this or not? So that's another really great thing about mastery grading, is that you can ask these types of questions to assess these things. Common challenges, okay? It is a larger volume of grading because you end up grading all the exams and all the reassessments. And the upfront workload is a little bit tougher if you actually do write all of your objectives and different versions of questions ahead of time. Or if you distribute it throughout the semester, like I do, at least the first time I do mastery grading. That is a big upfront workload. Writing rich questions and coming up with a good question takes work, time, and practice. As I mentioned, that first question that we had from algebra, if I wanted to assess if they were doing slope-intercept form, my question isn't a good question for that. So you have to be careful about those types of things. Another thing that I have found when I've been doing my research, and one of the things I do is I compare things from a traditional class that I've taught the same way as like my mastery. I noticed that, or at least this has been noticed with not just my class, but other people have actually like done like more of the study of it. There's a little bit more of a bimodal grade distribution. And I feel like this is because students can sometimes eke by with a D by getting enough pity points. I feel like when I'm grading, like, I'm like, well, they wrote something down. Shouldn't they like get at least 1 point on this? Maybe that's not a good way to grade, but I feel like you can get people who eke over and get kind of a D, but aren't really ready for the next class or didn't really like understand the class. I feel like mastery really shows you if you don't understand the concepts or not. On the other hand, I feel like a hardworking B student is more likely to reassess and get an A, and I'm all for that. So I feel like it's a lot better, or at least for me, even though it's bimodal, I feel like it's a lot better for me to see like this student did demonstrate and has a good understanding of this course. This student does not. But that's something we found. Some students, they are used to trying to get points and earning points. So sometimes it takes them a little bit harder to like get used to this different type of problem. For example, on an exam, I tell them it's better for you to do fewer concepts and master them than to do all the concepts and not master any of them. And that's kind of a different, like, I feel like it's more of a shotgun approach. Like, I'm going to really like try to like understand this part. Right. It also, yes, exactly. I'm always worried about memorizing. That's one of the things when I was doing mastery grading at first, but so far when I've like, at least from the like student surveys we've done, students actually seem to feel like they're memorizing less when they're doing mastery grading than when I've done my traditional classes. Because again, they're focused more on understanding, not just mimicking, I think. And another thing, students master concepts slower than you expect. Like, it's just like, it takes them a while and it takes a little bit of practice. Finally, I'll talk a little bit about some challenges in the grading. So even the perfect problem can have issues, and these are things that are the challenges, and I want to be upfront about like, these are some things that could go wrong. So like, as I mentioned before, you have a multi-part question to assess a concept, and the student gets one of them or part of them, but misses a small part on another one. That's a question of like, did they master this concept or not? It's a tough one. 5 of like in real analysis, sometimes I have a bunch of definitions that they need to know, and that's one of the concepts. What if they have 5 of them perfect and one they just leave blank? It's not even close. Linear algebra, showing something's a basis, they need to show that it's linear, independent, and spanning. And so it is a basis, and they pick the right basis, so they know it should be linear independent, and they know it should span, and they're kind of mimicking some work. So they haven't really justified that it's linear independent or spanning, or maybe one or not the other. And that can be hard, when you're grading. And finally, a student fails to provide a key component to the solution that wasn't explicitly stated, but assumed necessary for mastery. That's kind of like that question that we had for algebra. If I'm expecting them to show me slope-intercept form, but I haven't explicitly asked for it, that can be a little challenging to assess, of course. So other challenges, sometimes you need to justify switching to an alternate grading system with your chair or administration. You can use a lot of research that's completed from journal articles. The Primus Mastery Grading Special Edition has a lot of really great articles. Ensuring student buy-in, explaining to students why you want to do this alternate assessment that's different. I feel like it's very good to kind of explain to students why you're doing something. And especially if it's your first time, like kind of being upfront and making adjustments if you need to. So the last thing I have is the checklist when kind of planning to do this type of thing. So this was what we thought was kind of what you would need to do if you wanted to do this yourself. One is split the course into concepts, like however many concepts you want, list the student objectives for each of the concepts, decide on how you're going to do a reassessment. Are you going to do it in or outside of class, a little bit of both? This is one thing I forgot to mention. Before their first exam, I actually give them a mastery quiz. They get to pick one of the concepts that they want to do, and I give it as a quiz, that one concept, and I grade it on the mastery scale. And if they master it, it counts towards their exam grade, but it also gives them an idea of this is how it's going to be graded. That's a really great way to kind of prep them before taking a mastery exam of like, this is how it's going to be graded. And also gives them another chance to master something. So you want to think about how you want to encourage student buy-in. You want to think about the language in your syllabus. I'm going to have a Padlet that has a resource that has like a repository of a bunch of different syllabi who have used this type of alternate assessment, and you can pull from some of their great language. I'm also happy to share any of my syllabi. Writing the rich assessment questions, I feel like is the hard part, and I don't always do it before the semester, especially if I haven't taught the course before. And I also like be aware you can make adjustments. You can add reassessment opportunities. You can adjust the number of concepts. I know when we all moved online in spring of 2020, some people just cut like a whole section of their course, and that was fine. And you can always reach out for help and support if needed. There's a whole group of this like kind of standards-based grading, mastery grading. There's like there's Twitter groups, there's I'm trying to think, Slack groups. There's like a bunch of different resources and people who can help you. And I would be happy to help and happy to point you in the, like hook you up with someone if you want. So here are some of the resources. I'll go ahead and put this in the chat. So I made a little Padlet for like that has a bunch of resources. There's also a mastery grading repository that's in there. There's a grading for growth blog, which is really excellent. The Primus special editions. There's also the grading conference, which is a virtual conference in the summer, which is excellent and one of the best online conferences I've ever been to. And you can also email me and I'd be very happy to answer questions. So I'll stop there. I do have like, I do have some other like slides that have like, you know, here's what it might like your grade book might look like in Blackboard. This is how it might look like in Excel, which I'm happy to share if people are interested in taking a look at those things. But it's something I cut because this was taken from like a workshop that was over multiple days. And I know I kind of just did a bunch of info dump. So hopefully it wasn't too overwhelming, but thank you. For having me. Are there any questions? Yeah, I'll put the links in the chat for sure.